Hey everybody, Sukani here. So today we're going to be taking a quick look on the differential equation properties. So we have three properties outlined here. Let's go step by step. So first we have the order, and the order is probably one of the easiest. It's just saying the highest derivative. So of course this is an example over here, and we see the highest derivative, that's going to be 2. That's going to be the second derivative. So the order in this case is just going to be 2. Pretty self-explanatory. Next, we have degree, and this one, I would say you kind of have to wrap your head around. It's the exponent of the order when the differential equation doesn't have radicals or fractions. So first, we need to check if the differential equation has radicals or fractions. I know that in this case, the order is 3. So the order is 3, and the degree is going to be the exponent of that order. So basically that's just going to be 2 because that is the exponent. And now we have to check if it has any radicals or fractions. Nope, the coefficient is just x, and that's not a radical and that's not a fraction. So we're all good with that. Now, what is number 3? So number 3 basically classifies these differential equations into linear or nonlinear. So if any one of these are true, that means your differential equation is nonlinear. So first is that we have a degree that is greater than 1. Now going back to our second definition, we know a degree is the exponent of the order, provided this differential coefficient limitation. So let's go to our first example over here. The reason this is a non-linear differential equation is because the degree over here, you could see, that is 3, and that is greater than 1. So I'm going to write 3 is greater than 1, so it is not linear, right? Now for the second condition. The second condition is any differentiable coefficient greater than 1. So any differentiable coefficient greater than 1, we could see that right over here. 3 is greater than 1. So of course that is not going to be linear. And it could be any differential equation. It could be 4 over here. In that case, 4 is greater than 1. So we automatically know it's not linear. Next, we have exponent of the dependent variable is greater than 1. So the dependent variable is always going to be the variable at the top. So it says the exponent of the dependent variable is greater than 1. Here, we know that the dependent variable is y, and we see that the exponent is 8. And 8 is definitely greater than 1, so that is also nonlinear. And finally, at fourth, we see the product of the dependent variable and the differential coefficients are present. In other words, this is saying our dependent variable and the derivative is being multiplied together, so that has to be a nonlinear differential equation.